Okay. So I'm Dorothy. This is my undergraduate project that I just finished and graduated, so whoop, off to the next thing. So we're going to talk about plastics, which I'm sure you've heard in the news. Something that I want you to think about there are a lot of different kinds of plastics out there. We use plastics every day. You may have gotten a coffee cup lined in plastic earlier, or maybe you were really good and you brought yours from home. I forgot, but I did bring my water bottle. You have, where's my pointer? You have all kinds of different plastics. Water bottles, your hairbrush, if you eat to-go food, straws. As of yesterday, the plastic bag ban went into effect, so that's awesome. Even though the grocery store lady kind of grumbled about it. Have you eaten any kind of strawberries here in California ever? The little green guys, those are plastic. We have medical sterilization products that are really important that are plastic. So this isn't anti-plastic, it's just an awareness. The other thing that you may have heard about in the news is microbeads. And so microbeads have been in all kinds of products, things that you may or may not know, whether or not you're aware of it. It can be in your toothpaste, your face wash, your body wash, all kinds of different soap and personal products. In California, the ban went through, but the federal ban does not go through until 2020. So if you buy anything not in California, check the label. There's a way of doing it. There's not an app yet, but you can just Google it. It's pretty easy. The other kinds of plastics that people don't think about usually are fibers. This is something that we found a lot in the research that I've done. So you have different kinds of fibers. So boat rope, boat rope is a mix of polyethylene. You have cords of plastic fibers that are used in all kinds of different products. And then you have this stuff, which looks cool up close under a microscope, but it's like your favorite plastic bottle bag jacket maybe that you bought from Patagonia, or your running shorts or something like that. So those are all made with all kinds of different fibers. And the reason this is important is because when you do a load of laundry, there's upwards of thousands of fibers that are released into the gray water every single time that you do a load of laundry. So it's not like you're doing it on purpose. You have to wash your clothes because it's inappropriate not to, right? All right, so microplastics is the direction that I went. So microplastics is anything smaller than 5 millimeters. So you usually can't see them. I mean, sometimes you think you can, but you can't. So we have a couple different categories of microplastics. So the first part is stuff like bottle caps, like a whole G.I. Joe. If you don't know what G.I. Joe is, I'm sorry. Or like maybe a piece of the little strawberry plastic, something like that. Something that you can still recognize. You see what it is. The next is what we would call daughter plastics or secondary plastics. So this is a chunk, like a piece of the G.I. Joe arm, or like a chunk of the bottle cap. And what happens is these just get smaller and smaller. So somebody tells you that you can recycle your plastics. Not really. They just get smaller and smaller. They literally just degrade into dust. Michaela is going to talk next, and we've been out picking up trash, and you pick it up and it literally disintegrates into breathable pieces of plastic. Then we have nurdles, and we had a spill a few years ago off the coast of nurdles coming from Asia. So these are small little spheres that you put into a mold to make something in, so if you're making like a mold for like maybe 3D printing or something like that, that's what you use nurdles for. And then we have microbeads, which are itty bitty tiny things mixed in with itty bitty sand particles. So that just kind of gives you an idea of just how small everything is. So where does our trash belong? At my house, trash day is on Monday. You bag it up, it smells, put it in the trash can, roll it down the driveway, park it out so the trash guys come and get it from you. We assume that it ends up here in the landfill, right? Landfills all over the world. Some are managed better than others. I mean, if you're an environmental science person, you manage the trash and all the gas that comes out of it. But what we've found is that it doesn't always end up there. It ends up on the side of the road. And so this is a little spot literally on the side of the freeway where I get off to go surfing. And there is trash all the time right here. So it's dry because we've been in a drought, but every time it rains, all of that water gets gushed into one area and shoots all of that trash out into the ocean eventually. So then we see things like this, which is gross. So this is a picture from last year when we had a decent rain event at the Los Angeles River right before it goes out into the ocean. And then you guys have probably seen stuff like this if you ever go out on a boat, if you're a diver. This is something that Michaela's going to talk about too, is marine debris. So leftover big chunks of floating plastics. The bobs that go on top of the lobster trap or fishing net. These are the kinds of things that float on top. The difference is plastics have different densities, right? So the ocean is salt water. So certain plastics float, but most of the plastics go down to the mid-range and then to the benthic level. So then you ask, well, how do we end up with this kind of plastic up in the ocean, moving around? Well, there's wave action and everything else. So cigarettes actually sink. Gas stuff, your soft drink bottles, like if you buy a Coke out of the machine, stuff like that, your fibers from your clothes. What we mostly see on top are, bottle caps, the floats for lobster traps, and then our good old plastic bags that we're trying to get rid of. But this is why we deal with marine debris issues with marine mammals, is it's that entanglement area right here. So this is just kind of an idea of the different changes. So it's not just the stuff that floats on top. That's just the easy stuff that we see, that people take pictures of and put in the news. And it's really great when you're talking to somebody because that's what they're going to think about. So as far as an easy way to test would be the beach, right? So I live near this beach. You can walk down, it's really cool. There's a naval base down here. When you look at this beach, it looks pretty nice. Obviously, we had some big waves this winter to knock off some of the sand. It's actually really good surfing right here. But you think of these beaches as pretty clean, right? When you go to the beach, you don't want to see a bunch of trash. Well, what we saw was when we got up to the shoreline is this. And so this is micro trash. This isn't really microplastics per se. Some of it is. I don't have a scale, of course. But this is a piece of a straw, a little chunk of unidentifiable plastic, and then some leaf litter that was left over because there's a tree really close to this spot. So this is what we saw. So we decided, well, maybe we should figure out how bad of a problem this is. So with help, we collected sand from 51 beaches up and down the coast of California, so all the way from Marin County down to San Diego. What we did is I went out and scooped up sand from the strand line, so the dry area, and then in the shoreline. Took it back and you mix it up with super salinated water. And what that does is it helps float out most of the floatable plastics. And then we filter it onto these cool glass fiber filters, and you can look at it and identify it basically by color and size and shape to see whether or not it was like a fiber or just a chunk of plastic, something random. And it's kind of cool looking at sand under the microscope. So this is the stuff we found. So remember in the beginning when I showed you that picture of all the products that have microbeads? So in order to see this, I took a product from, I don't know, it's like a skincare product, and I filtered out everything that wasn't like a solution. So I got a ton of microbeads. I filled up 3 huge vials of just microbeads, and then I found nasty stuff that looked like this. I didn't think too much about it until I found this in a sand sample. So this is the goo that kind of holds your face wash together, and it doesn't go away. It doesn't degrade. It's actually like a plastic snot material. It's kind of gross. It's little, oh, there's my skin. We also found microfibers, and this was definitely the abundance that I'll show you in a technical graph in a little bit. This is most of what we found. So different colors, different shapes. Some of them are really small, some of them are wadded up. Some of them are really obvious, like it's hot red or hot blue, a lot of them are black. There's been a couple studies out there that show the longer these things are in the environment, the more they taste like food to all of the critters. So that's fun. Little bitty stuff. So this is a fun graph. Okay, so this is my sand graph. Up here this is the number of fibers or particles. So this is from north to south, this direction. That's Rodeo Beach, which is San Francisco-ish area, and San Onofre, which is where the nuclear plant is. And this is what we found. Every single beach had something in it, some kind of microplastics. So a lot of fibers, which we thought was probably obvious, and then some had particles. And there's no real rhyme or reason to this. So this is a beach here that's out at Santa Cruz Island. So this is an uninhabited beach. And then we have beaches like close to where I live, Silver Strand, that was just tons of fibers. So we're looking into to see the different degrees, which is something Michaela's going to talk about, where it's coming from. So this is my sand crab. So we picked sand crabs. We figured out that the sand itself is full of trash and microplastics. Sand crabs are the most abundant little invertebrate that lives in the sand. They're cute. Everybody knows what they are. Well, almost everybody. They're filter feeders, so they have these cool little feeding appendages that I'll show you in a minute. And we figured because of that, they had a fairly high potential for microtrash ingestion, so it was a great thing to study. So, sand crabs are also cool because surf perch eat them mostly, 90% of their diet. Surf perch are used shore fishing. So my dad's a big shore fisherman, and he knew exactly what I was talking about as soon as I told him what I was doing, because he said, oh yeah, you just dig your hand down, throw them in the bucket, and they're great for bait. So over 2 million sand crabs a year are used for that. Shorebirds eat them, and then as well as sea otters eat sand crabs. So they do go up into the food web. These are the sample sites of all the sand crabs that were collected. So these little triangles all up and down the coast. There are gaps because I live down here, and so I had help. People would send them to me. In 38 beaches across California, I collected about 10 crabs per beach, and then identified the different things that we found by shape and color. This is a microfiber inside of a crab gut. This is the one that was actually embedded in the tissue, so it's not just being passed through. This is the first microbead I found from an Orange County beach, so it was really exciting because the microbead ban had just passed. So this is the overall data for all the sand crabs. So starting from north to south, as you can see, every single beach that we tested, there was at least one crab that had ingested microplastics. So on the axis here, you can see this is the proportion. So basically for Mission Beach, we had 1 out of 10 that had ingested. Silver Strand, where I live, we had 9 out of 10 that had ingested some form of microplastic. And these are beaches along the coast as well as out at the islands. So there's no real rhyme or reason why and when they're getting the trash. So it's everywhere. Overall, 35% of the giant group of sand crabs that I grabbed had some form of ingested microplastic, and all of the sand that we've looked at has had microplastics in it. We wanted to be able to identify that they were actually plastics, so we used this fancy microscope here. I didn't get to use it, we had a tech that did it. We found polypropylene, which is regular plastic containers, polyester, which I talked about, like your workout jacket. We found tile caulk, which is a really long word for that, polyethylene, microbeads, and plastic bags. Polyacrylate, which is just another form of plastic. And then we also found non-plastics, cellulose, cotton, and synthetic cellulose fibers. This is just a subsample of some of the stuff that we found. So then I wanted to see if there were behavioral effects. So if sand crabs are eating them, I don't know if it'll play. This is what you can tell is these are their little feeding appendages. So they burrow like halfway down, and as the waves come over, this is how they feed. Sand crabs are fun. So this is a gross picture. So sublethal effects. So parasites have already been shown to cause slower burrowing speeds. So as they go into the sand, if they're full of parasites, it goes slower, which then the birds eat them and it transfers up into the food web. We just confirmed this because we timed the burrowing speeds. And then we wanted to see if microplastics had any effect, the same as sand crabs, and we found that it was completely independent. So having parasites does not equal microplastics. For every group of crabs, the most was like 3 pieces of plastic, and the least was 1, that was our mean. And so we found that ingesting those microplastics did not affect the burrowing speed, so that's a good thing. But what we're looking is maybe it passes through the system, or maybe it transfers some kind of chemical, and that's the next thing we're testing for reproductive effects. So this is our pathway into the food web, into the otters, the birds, the small fish, and the big fish is what we eat, right? So then we end up with plastic in our food. So think about that when you're paying attention to when you order your stuff. We eat at the very top of the food chain, and surf rider is a very fun picture for me. All these plastics attract extracurricular pollutants. They have additives already, and the issue with these pollutants is when they're transferred into tissues, they cause endocrine disruption, immune response problems, and reproductive issues. So the take home with this is microplastics have been found in every sand sample. It is a new pathway of ingestion into the coastal food web, and these are harmful. So what I want you to think is when you push your trash out to the curb, it's not necessarily going here, it might be ending up here. So really pay attention to what you're using. And thanks a lot. Thank you.